Welcome here at Franz. Actually, we're on the 7th floor, but we don't have a conference room that can accommodate so many people. The reason why we do this is, well, on the one hand, I try to at least once or twice, well, once a year, get at least to the meetups. Hasn't worked out last year. But I'd like to show some cool things that we do here at Franz, and also we're hiring. And we're trying to find programmers to work on AllegroGraph. So I'll just hope you have a good time here looking at what we do. Hope you'll like what you see and tell yourself or your friends that there might be something for you to do here. Yeah. All right. So what I'm going to talk about today is a few minutes about Franz as a company. Then I'll talk about the main product, AllegroGraph, and its technical background. And my first question is already, who has worked here with a graph database? That's great. So who has worked with RDF? Okay, one more time. You did 2, 3, 4. Okay. So that means I'll go a little bit deeper in what is an RDF graph database. Yeah? So I'll talk a little bit about the technical background, and then I'll just mostly keep doing demos and talk about use cases that we do for customers. I'll talk about the linked open data cloud. Anyone heard of the linked open data cloud? One? Cool, I got something to tell then. I'll give a demo of what you can do when you take data sets from all over the world, integrate them together, and well, the power of that. And then most of my talk will be about a product that we're building. It's called the Semantic Data Lake, which is the combination of AllegroGraph plus Hadoop plus predictive analytics and machine learning. Yeah, and I'll do also some demos for what we do in that area. We actually have data from 2.7 million patients in the New York area for 10 years of data. We've got everything you can imagine that you generate about patients. We all have it available in a big data warehouse, and we're transferring it into a semantic graph in Hadoop, index it with AllegroGraph, and then you can do amazing things if you have so much data available. So I'll show that. And so how much time do I roughly have, Arthur?
I think an hour maybe, but less if you...
Oh, no, that's okay. So I'll try to keep it at 35 minutes about what I do, what I talk about. Because then we're going to talk more about the Lisp, because Aasman built most of the backend in AllegroGraph, and because this is a database that's used by many people in production. It's just a full professional product. I mean, we had to do a lot of new things in our Lisp, yeah, to make the Lisp ready to be able to deal with that kind of professional demands. I mean, it's a true database, and there's not like a game, but you really, really need to be serious about it. So Aasman is going to talk about some new techniques that we had to invent. But this is also like a great example of a company using its own dog food. Yeah, where we have the Allegro Common Lisp compiler. But we usually were only focused on it as a compiler to sell. But right now, yeah, all our companies are actually using the product, the Allegro Common Lisp, to build AllegroGraph, which has been also a very interesting experience. And Aasman is going to talk some about that. Okay, so let me start about Franz. We've been around since for 34 years. We started in Berkeley, now here in Oakland for the last 5-6 years. Well, actually 10 years in Oakland, but for the last 5 years in this building here. When I explain it to other people, I say, well, what are our flagship products? Allegro Common Lisp and AllegroGraph. And if you look at where our customers are, we actually never had a real niche. I always say we go where complexity is. Yeah, and I tell people, if you already have a spec and you know exactly what you want to build, yeah, just use Java, or because it's much easier and cheaper to find Java programmers to get your thing done. If it's a really complex problem, you haven't kind of figured it all out, then Lisp is the perfect language, yeah, to kind of explore, make mistakes, and then get to the point where your product works. Okay, then I like to show this picture to most people. Can you see it in the back? There's 2 seats here with yeah, okay. that I'd like to show. I mean, Aasman actually created a product that runs in all the Boeings. What is it? How would you explain it in one sentence?
It's an NFS server.
Yeah, that makes it possible that multiple systems all can talk to each other. But Boeing itself is a big customer of us. One product that they use is a controlled English language. So Boeing is making. So Boeing has mechanics in God knows how many different countries in many different languages. So that's a problem if you make a new manual for how to repair something. How do you do that in countries where people don't really speak your language? So they came up with a language consisting of 1,100 words, nouns, verbs, yeah, and engineers are forced to write their documentation and their instructions in that particular language. If you want to use a new word, it's going to be a big committee fight to get that thing in there. But the cool part is because it's controlled English language, they can even derive Gantt charts from the text. So they can actually go through the instructions, have a computer interpret it, and see if it's even possible for a human being. And they have found that engineers were writing instructions where you actually needed 4 hands to do the thing. Like, take this thing, now take this thing, and you think, okay, where's my other hand? Yeah. So anyway, that's one system that they use. But they also have kind of a spreadsheet of the entire Boeing 747, I believe, in memory. Yeah. And every component is in there, and then if you change one screw from copper to, I don't know, stainless steel, yeah, you have to recalibrate the plane for all the constraints that you might have. They tried to rebuild that thing many times in different languages, still using the Lisp version. And yeah,
I wondered about the controlled English, where they're also controlling the syntax.
Yeah, and actually Ford is doing the same thing. So there's several companies that use Lisp for controlled language. Very interesting project. I have a great story for each of them, but I don't have much time. So then 10 years ago, we started building our Semantic Graph Database. And initially, all our funding, so by the way, our company is privately funded. We don't have any VC money or anything. We're just a company that has to live from the things that we generate. And so we used the revenues from our Lisp to start building a new product, AllegroGraph, and then you sell, your customers tell them what you really want. And so all these customers that you see there have licenses to AllegroGraph, and some of them are using them in production. For example, the US Army was our absolute first customer to use our graph database, where they actually matched the very complex profile of a soldier with about the 100,000 different types of courses you have in the army, and a soldier always needs to do some education, and this was a program to match the needs of the army and the soldier with the complexities of courses that you can take, and that thing is still in production. But BAE in San Diego is also a big customer of ours. They work with the National Geospatial Agency, where they take all the satellite pictures and then they have machine intelligence to interpret the objects they see in the satellites. And then the interpretations of that, the metadata, goes into an AllegroGraph. And then you have human beings that look at pictures, and human beings are still a little bit better at it than machines. So they also make notes about what they see in particular satellite pictures, and then a big AI program is every day looking at all the data to kind of create stories about what might happen. Like, oh, I see in this spot, I've never seen trucks. What are they doing there? Then I see a lot of people going there. Yeah, so it's like new patterns in the world that they try to figure out from the satellite pictures. Very interesting work. So that was the first 4 or 5 years, and actually the intelligence agencies are still a customer of ours. But we also got more and more into the commercial world, and now all the pharmaceuticals have licenses to AllegroGraph. They have by far the most complex data structures in the world. Yeah, the data structures that describe everything in our body, physiological processes, the chemical processes, the genetic stuff. Yeah, it's just very complicated. There's no way you can even begin to represent it in relational databases, so they represent it in a semantic graph database. So they are the furthest ahead in the entire industry in using semantic technology. But this year we also talked to every bank in the United States. None of them are really big customers yet, but they are focusing a lot on building vocabularies and terminology systems, because all of semantics starts with use the same word for the same thing, because how can I compare things in my companies have use different words, yeah, for the same thing. So that is what banks are doing, and then the next step for them is fraud detection, compliance, and knowing more about your customer. So the kind of application that we see coming. But for us as Franz, so we always had Allegro Common Lisp, and it's like a horizontal product. You have to sell. You can't sell to anyone, but that's a downside. Yeah, you're not solving someone's problem. You're selling a tool. So then we got AllegroGraph, which is also it's much higher in the value chain, but it's still a tool, and you have to train people. So we now got to a situation where we can actually apply AllegroGraph to a use case in healthcare, and it's very likely that that's becoming for us a very new big focus point to do this thing I talked about, the semantic data lake, where we can actually solve hospital problems, and I'll get into that in most of my talk here. Okay, so most of you guys know what a graph is, yeah? So usually when I talk about it to people that don't know anything, I say, well, let's say I want to represent it as a person. There's the name Jans Aasman, is 54, actually 57, lives in a place in Moraga, which is part of a state that is California. Yeah, that's part of a country in the name USA. And there's another person that's living in Yonkers in New York, which is also part. And these person 1 and person 2 were recently in an event where that was at a particular date in a particular place. Yeah, and these were the 2 actors. And so, yeah, I describe in the graph the 2 people from various places met each other. So this is, everyone sees and knows that this is a graph. AllegroGraph is a Semantic Graph Database or an RDF graph database, where we actually care very much about how we name the nodes in our graph and the links between the nodes. Yeah, in Neo, anyone use Neo4j here? Okay, so in Neo4j you can use any identifier you want, but there's no standard about how you name these nodes and the links between the nodes. Yeah. In our community, the semantic web community, we use a standard from W3C. It's called RDF. Yeah, where you actually use URIs, yeah, to name your nodes and the edges. And the example, the big advantage of that is that you can have people in different places create their own repositories of information using this RDF standard, and you can just take all these databases together because and they are integrated, because people in our community really care to make sure that they use standard names for things. So now, okay, I'm running ahead of myself because this is a graph, but AllegroGraph is an RDF graph database where we represent this graph actually as what we call triples. Yeah. So here you see person 1 name Jans. Well, in the triple it's person 1 has name Jans, person 1 has name, last name Aasman, age, lives in. Yeah, so you can represent the graph in triple. So that's what we do as a product. So, so what is so if you look at AllegroGraph, everything is built from the ground up. There are several triple stores that are built on top of relational databases. Oracle does that. There's an open source version called Virtuoso that does it on top of a relational database. We built it from the ground up, mostly Aasman sitting here. It's what we call a schemaless quadruple store, where each part of a quad can be anything you want. We don't care what you put in there, a number, a string, a date, yeah, we just take it. So that is just the background. Then we have these think of it as a relational database with 4 columns. Yeah, that's all it is. Except we sort these columns in 6 different ways, so that it becomes very easy that if you want to get any tuple out of your database, you can give any combination of S, the subject of the tuple, the predicate of the tuple, the object tuple, or the 4th element, the graph of the tuple. And we always find the right index for you to, with 1 disk access, go to the spot where your data will be. Does that make sense what I'm saying? I'm going really fast here. Yeah. And so, should I say more about
What's
it?
I? I didn't get I.
Oh, every triple has a unique number.
Oh, and so you can look it up by that number. I got it. Okay.
Yeah, it could
Is that
say
the same as the reification of the quad?
you can use some people use the fourth element of the triple for verification. For example, you can say Jans weighs 70 kilos, yeah? And then the fourth element would be statement 1, and then statement 1 would be statement 1, no one believes, etc. Yeah, so you can just say many things about a triple. So reification is a word that means that you have a statement and then you make multiple statements about that statement. So in our system you can use the fourth element for that, or you can use the identifier. You can say triple 1, and you could say Jans weighs 70, and that would be triple, graph, and then 1, and then 1, and then whatever you want to say about
It would be
triple number 1.
Okay.
Yeah.
Okay, thanks.
I'm going to skip the rest of this slide. It's not interesting here. So I told you it's a professional system. Yeah, I mean, it's used in production. Our customers value it very, very much that we're a completely asset and transactional database. Yeah, with everything you expect from an Oracle. So commit, rollback, checkpointing, 100% read concurrency. We recover if you pull the plug. Yeah, and you start the database up again, it recovers to the point where it was. We can do online backups, point-in-time recovery, replication, warp standby. So all the things you expect. And then one thing I always like to point out to analysts, so I left it in this slide here, usually I take it out, but if you ever start working with another graph database or another semantic graph database, please do this little test where you do several hundred transactions per second and look at vmstat in Linux to see if they actually save the data to disk every time we do a transaction. Because many of these cheat a little bit and they buffer it up and then they write it out at some point. Yeah, Aasman and I looked at databases and we were highly surprised that the data actually wasn't stored all the time. Anyway, anything else I want to say here? Oh yeah, in the intelligence community, but also in the hospital world, it's very important that you can prevent certain people from seeing certain triples. Yeah, for example, only HR might be allowed to see the salary of people or some other features. So we can specify on a triple by triple basis, based on whether your username and the role that you have, whether or not you can see a particular triple or not. Yeah, this is a unique feature that we have. Then we do our own advanced text indexing on top of this. It's a shared, how do you call it? An SMP-based model, so shared memory. And this is where Aasman is going to talk about. And then we have to have what we call dedicated and public sessions. It's also going too deep here, but say you work with our database and you want to experiment by writing some rules in Prolog to figure something out, then you can ask the database, give me a dedicated session. You can build all your own rules in your own session, and the other users won't have anything to do with your rules. You can just experiment as much as you want. Yeah, if you want to and it finally works, then you can put it in your init files and then everyone can use your rules. But it's a very powerful mechanism to kind of give people their own view on the database where you can do very complex stuff. Then I skip this slide. Okay, some unique properties that we use in our marketing. We now have a feature for n-dimensional indexing. So say you have an intelligent, anyone works here with the R trees? Yeah, okay, so you might have, so we have several patents on geospatial indexing, yeah, where if you normally do a join in a database between the latitude and the longitude of the database, your joins can get really big. Yeah, so in the database industry, we invented two-dimensional indices, where you could use a particular B tree in 2 dimensions, or we have our own technology, where you put these two latitude, longitude in one object, and you use a technique so that if you want to find something, you can use one disk access to get there. But we made it even bigger, and we now can have up to 7 dimensions in one value. And that's important, for example, for the intelligence agencies, because they want to say, give me all the phone calls from this time to this time that were made in this particular geospatial block. Does it make sense? Now again, if you would record all these things separately, you would get incredible join times. So with this, you can kind of directly get to the point where you want to be. Again, I'm taking too much time for this. Some other things that we have is we have the query language that we use is Sparkle. Anyone heard of Sparkle? Probably only a few. Okay, it's like SQL. It's like a weird mix of SQL and Prolog. It's a standard from the W3C. We do have a full Prolog compiler in our product in Allegro Common Lisp, and so you also can use it directly with AllegroGraph. So you can write rules and rule systems in Prolog. Yeah, and you can make that available as stored procedures to other users. I use Prolog a lot. If I write code, it's kind of a weird mix between Lisp and Prolog, because you can mix these two languages very easily together. It's a very interesting way of programming. And then we have a JavaScript compiler in the product. So if you want to write stored procedures in Java, this is for people that are afraid of Lisp. Yeah. So well, we needed a solution because people say, I'm not going to program in Lisp. I know, I can't do that. So we wrote a JavaScript compiler. We have a compiler company. So if you want to, you can, yeah. Anyway, you get my point. And then we have all these libraries for geospatial reasoning and temporal reasoning, graph algorithms, social network analytics. And we are the only company in this space that actually has taken all these libraries and made them available in the query language directly. So here is a Sparkle query that you probably can't even read in the back. And I only want you to read this part here. This is a proof of concept that we did for PayPal, where you had accounts and then you had transactions between accounts. And so you can look at a social network between a particular account in terms of the payments that someone made in your friends and friends of friends network around a particular person. Yeah, but also payments are made at a particular time, payments are made in a particular area, accounts are made in a particular area. And so PayPal is very much into fraud detection. They needed a system where they can both look at the graph, who pays whom regularly, and then you look at when payments are made and where they are made. And so I don't even want you to read this part here, but what it does is it answers the question, did the most important friends of Montefiore make a payment within 100 miles of Mineola in the last 10 years? Yeah, many different capabilities, yeah, geospatial, temporal, social network analytics, all embedded in one query language. Very powerful paradigm. Okay, so
Is this friendly to MapReduce environments where you have multiple machines? Or does it need a single processor with a core?
That's what we're going to talk about in the healthcare case. Yeah, you don't have to be too nostalgic. It's still there, the healthcare part. Yeah. So let me start with some demos. So this is a graph. Okay, so people started working on the standard RDF about 15 years ago. Tim Berners-Lee was one of the big drivers to make semantics an important part of the web. His reasoning was human beings can read web pages, but computers can't. And the reason is we haven't marked it up in a way that computers can read it. So he came up with this idea, we need a new format to mark up information in a web page. And he came up with the idea of triples to represent markup in a web page. And so we started that, but now 15 years later what we see is that microformats are beginning RDFA in web pages. JSON LD, which is the RDF version of JSON, are beginning to well, you start to see them in web pages. But what's actually more interesting is that you see that you can now download thousands and thousands of files on the web with databases encoded as triples. Yeah? So in the demo that I'm going to do, and you can't see it from a distance, I'm afraid, but I'm going to download. So every circle that you see here is a few million to literally a few billion triples. Yeah? The biggest one in the middle is DBpedia, yeah? Which is the triple version of the Wikipedia. Yeah? So all the information boxes from the Wikipedia are turned into triples. They've been working on this now for 7-8 years, working very hard to make it easy for computers to deal with it. And you see all the lines between them, and that is that people all make sure that you can link from one database to another database. So if you create a relational database, if you guys get the job to make a new relational database, yeah, then there's not a single neuron in your head thinking about how's my database going to work with that database. You don't think about it. Yeah, you got the task and the specification to solve a problem, but hardly ever do people from the start think about how's my database going to work with that guy there. Yeah, so you make only foreign keys that make sense for your own database. You don't make foreign keys that can point in other databases. Well, in the demo I'm going to show is 5 data sets that I download from the web. There's one database with 100,000 clinical trials, a database with 1,800 FDA approved drugs, a database with 4,000 diseases, 4,000 side effects, and a list of all the brand names for medicine. Yeah, and yeah, so this is the same picture again. So clinical trials, diseases, drugs, brand names, and side effects. Note that all these lines, because clinical trials talk about diseases. Yeah, diseases talk about drugs link to diseases, drug links to brand medicine, but to side effects. So it's kind of all a big graph pointing to each other. And then, and I'm not going to talk about it today. I can even see. I also have patient records, 3,000 patient records that I indexed with Mesh and SNOMED. Anyone heard of Mesh and SNOMED? Very good. So in the hospital world, yeah, if you want to do anything interesting, you better use the same word for the same thing. So the hospital world has actually 8-9 different terminology systems that define the words that you use in healthcare. And the two very important ones are Mesh and SNOMED. And I use those guys to index the patient records, but also all the unstructured text in clinical trials. So now everything fits together. And then here's my demo. And by the way, we built this demo for Pfizer originally, who wanted to link their internal databases to the external databases on the web. Let's see. So I have all these triples downloaded. Let me actually show you one file, the typical file that you can download. So you would say download drug bank RDF. And then when you find all these databases just on the web, you just click on it. Usually there's some kind of some Creative Commons license, or they're just completely free. You can just download them from the web, yeah, and even get an address somewhere. Yeah, so you can get your N-triples from here. Yeah, very simple. You download it from the web, and then let's see here. C, Dropbox, Lisp, Smart Logic. Data. Oh yeah, this is some. Yes, so here you would have, where's my mouse? Oh, there. So here are triples, yeah? This is a typical, so let me see, what is, ask me for a disease.
Diabetes.
Yeah. So here you see a triple. Disease 319. So 319 is actually a international number for diabetes in one of the systems. Has the name diabetes. Yeah. So this is just one triple. And then there's lots of other things. There's something else that's interesting. Well, there will be many more about this disease, but this is an example just about one triple saying something, very minimal in this case, about disease. Yeah, so you have millions and millions of these triples there. Yes. Okay, so now let me go get this thing. How do I get rid of this amount? They put them there, yeah. So, can you give me a drug that you like? Yeah?
Allopurinol.
Huh?
Allopurinol. A-L-L-O-P-U-R.
This? Allopurinol?
I can't,
Is
yes,
that the
I
top?
can't see that.
Is that the top?
I know, that's right. That's right. So all these triples. So I'm selecting 3 clinical trials that somehow, somewhere in the clinical trial, talk about allopurinol. Yeah. So look at it. So I have these clinical trials, and this is what we call the graph view. I can go to the tab view. Can you guys read it in the back? Yeah. Okay. So this would say this clinical trial has the brief title. So this is the subject of the triple, the predicate of the triple, and then you get the object. It says intravenous allopurinol to improve heart function. Yeah, in something. Here are some criteria for when you can be part of this trial. Here is the description of this clinical trial. Here are some diseases described in this clinical trial, some drugs, some side effects mentioned here, and everything else. So let me click on before I do anything. So you see this, and it's pretty readable, yeah? But underneath is RDF. So if I hit the letter 8 here, then you see actually the underlying RDF. Does it make sense?
So there's a triple somewhere where all that text description is part
Yeah.
of that triple.
Yeah. So everything is built of URIs, but when we show it in this tool Gruff, we look to see if that thing here has a label. So let me click on the disease. You see disease 196, yeah? If I click 8 again, you see it's myopathy. If I click on this one here, I see the genes associated with this whatever it is. Yeah. You see some possible drugs. But here you see the label. Yeah. So when we have a particular term and we have to show it in this tool, we look if there's a label. Everyone in this community makes sure that you use RDF label as the mechanism to give a thing a human readable name. Yeah. So we have this here. And then the other thing you see this thick line here. You see above this thick line is everything where the first part of the triple is cardiomyopathy. Under the line are all the triples where it's actually the last part of the triple. Yeah? So we can show both. So I can click on some other clinical trial that talks about this. And I can click on a drug. So now I'm in the drug database. Yes, I hope you. So I downloaded 8 sources from the web, put it in one tool, because the names are all linked up. I can now jump from one into the other. It's still one database, yeah. So I hope you understand what I'm trying to convey here. Yeah. So this is the drug, and I can look at the chemical formula here and how it works, the pharmacology of it, disease targets. Some more chemical stuff here, synonyms, etc. Yeah. So I'm going back to my graph view, and you see, all the things that I visited so far. So I'd like to go back again, the state where I was, and I can also explore this graph on the screen. So I can select the predicates in this system. That means all the things that connect 2 nodes together. And I usually go through this by clicking on the diseases, drugs, side effects, and targets. Yeah, so I'm selecting 4 predicates from all the predicates that I have in the system. And then I can say, so how are these guys connected? Yeah. And there's actually not even a short. There's a shortest path. How are these guys connected? So it looks. Does it make sense? Or I can just click on one. Oh, I don't like that's too much. Yeah. So I can keep going. Clinical trials. I can start. Yes. So I can explore this graph on the screen. Actually, I can do it. No, let me not do this yet. I can also click on something here at the top, and I see all the things that might be on the next step. So let's say I take the drug type and the chemical formula. Yeah. Yeah, so I can explore this here. I can show this graph also in another layout. If I go on the bottom left, yeah. Actually, I like to, for my demo, I like it more like this. Yeah. So I have various ways to look at this graph. I can explore as much as I want, but now I want to take a completely different term and link it to this graph. So have you guys any other word that you want me to look at?
Related to medicine?
Okay, so I always wait 10 seconds. If I don't have anything, I do. I'm already doing romantic kissing. So there's one clinical trial. Yeah. That's effects of romantic affection on blood chemistry and immune parameters. And what they found is that the more intimate you are, the better your immune system. Yeah. So tell that to your partner. And the question is, can I link a clinical trial like that to something about allopurine, whatever? Allopurinol, yeah? How would it be related? Oh, this is bad. It's directly related. Okay, well,
Try saw palmetto.
say that again?
Saw, S-A-W, space palmetto. To this
And then
palmetto, the plant.
Palmetto.
oh wow, I've never heard of that.
Would be related to the.
Okay, so, but yeah, does it relate to this here?
No, not to allopurinol. No, it would relate to the second drug
Oh,
that you mentioned, as in the love potion.
okay. Well, the whole point I just wanted to make is that this is. I selected these 4 elements, these 4 predicates, and now I use those as a generator in graph terms, yeah, where the input is one node, the output is the set of children of that node, and then you can do a depth first, breadth first, whatever kind of search you want to do to link things together. Now, I should not have done that. Well, that's small screen there. Too much.
Is there an undo?
Well, that is actually the coolest. That's a very cool thing because I can always go back and forth. So I can always, go back all the way to wherever I was, which is the most important function. When I teach this thing, I let people write it in the hand. Z, go back. Okay, so now you have this, and we looked at this. We got this, and say I find a very interesting pattern in here. I say, I'd like to see more about how this all connects. Yeah. So now I have a subgraph in this graph. I can take this subgraph and turn it into a query. So we have this here. Yeah. And if I now run query, it doesn't do anything because it's only constant. So it's more fun to take some of these things in here and turn them into a variable. Clinical trial 1, So how many times can I find a link from allopurinol to a clinical trial that discusses cholesterol, that discusses also hypercholesterolemia? Yeah? Say again?
I venture to guess quite a lot. I said quite a lot.
Yeah. Oh yeah. I'm just taking the first so many. So here's the visual result of this query, but let me go back. I can also say, well, I'm interested actually in everything in between. Yeah, so I'll say drug, and I want to get all the properties of this drug. So I make another one. I make a new node variable. I call it whatever. Yeah. And I say, show me everything else that I know about that whatever thing. Yeah. Link. And so now I can run the query again. Yeah. And I get a. But I hope you get the point. Yeah, I can write queries, very, very complex queries, just in a visual way. It automatically can translate it into this query language here. Yeah. So this is the query language called Sparkle. What can I say about that? Anyway, I don't want to go too deep in that right now. Yeah, because I want to go to the use case that I give it up to Aasman. And I'll keep it very short, Aasman. I know you want to go. Let's see. Huh? Okay. Is there any questions about this? So this is just was a demo. And we have all these use cases all over the place, but our new big thing, as I said, is to use this in healthcare. And we call it the Semantic Data Lake for healthcare analytics. We started working on it about 2 years ago, and we worked together with the Montefiore healthcare chain in New York, but also with Cisco, Intel, and Cloudera. Yeah, they're all partners. They gave us a set of machines that we can work on, and Intel demonstrated it for the first time in April of this year at HIMSS, the biggest healthcare conference in the United States. And the goal for the hospital chain was to make a platform, one single platform for any kind of query that you have. Usually what people do in healthcare is you build a data mart for every query that you have, and it's very expensive. Yeah, but they wanted to bypass the whole data mart thing. They said, okay, give us just one big data dump of everything in Hadoop, yeah, and then we want to do an analysis just straight on the data. So that's what we did. And here's all the things that we can do. We can do personalized medicine. Everyone knows what it is, yes? You have a patient, you the very specific patient, you have a particular kind of cancer. There's 5 ways to attack the cancer. What is the best way for you, given your genetic makeup and everything else we know about you? So that is personalized medicine. But this is translational research. Is okay, what is the best treatment for this particular disease? What can we find in our data that says what the best kind of treatment is? The insurance industry is very interested in fraud detection. And I don't want to go too deep in here. Yeah, but anyway, one platform, many questions. It's a system that they want to use both for the hospital administrator. Hospital administrators are very interested in, say, accountable care quality measures. But a medical researcher and doctors and nurses have completely different interests. I'm not going to explain it today too deep, but you guys are familiar with accountable care. Yeah, you read all the news about it. And the biggest change that happened is that hospitals in the accountable care no longer get paid for how many services you do, but for whether or not you make your patient better, yeah, for less money. Anyway, so hospital administrators never really cared, and that's unfair for me to say that, but they never really cared about their patients getting better. They care about the financial well-being of the hospital, so they want you to sell as many services as possible. But in accountable care, it's completely reversed. You get only money if you do better than others. Yeah. So if you now do 3 MRIs, you won't get any money for that, because it's anyway. How do I?
Isn't that test suppression?
Huh?
Isn't that suppression of testing?
Not necessarily, because the idea is that if you should have done that and you didn't, then in theory, over a long enough time period, you'll say, you're providing a worse outcome.
Yeah.
Assuming that we can do that, but the problem is finding those outcomes, right?
Yes. Yeah, the point is that you take all the hospitals together, you look at the averages. So you say, well, if someone comes in with this particular heart condition, yeah, how much money in general do you spend on that? And say it's $80,000. Well, if one hospital charges $120,000 for the same condition, yeah, but doesn't have better outcomes for that heart condition, then the government will give you a fine. If you could fix that patient for $60,000, then you get a bonus from the government. Yeah. And another thing is that if, for example, if you come back within 30 days, yeah, all the costs are for the hospital. Even if you have something completely unrelated, if you get in for a heart transplant and within 30 days you stumble and you break your leg, you go back to the hospital is basically responsible for your broken leg. Yeah, because you probably were still dizzy from the medicine or whatever. Anyway, the whole point is that hospitals now deeply care about understanding their patients. It's become very important. And so you need to do data analytics, but the queries come from literally everywhere. So I'm going to skip this one. So what is the current approach to healthcare analytics? It's just you take the EMRs, the financial, put it in the data warehouse, you create data marts for each question you have. The problem is these data marts themselves can't talk to each other, and each data mart itself takes about 12 to 18 months to build. It's very, very expensive. Yeah. So our new approach is to take the EMR financial data and then instantly take the data out of the out of these source systems, turn them straight into triples and dump them into Hadoop, the Hadoop file system. We do the same thing for all the other internal data, so unstructured notes and text, the tissue bank, clinical trials, clinical devices, everything you have within the hospital about a patient, but also you combine it with information from outside the database, outside of the hospital, NIH drug interaction databases, genome databases, clinical research networks, census database. It also goes as triples in Hadoop. Then we index everything with AllegroGraph, yeah, and then we have one huge advantage, and that is every query in healthcare is basically about a patient. Give me a patient that, find all the patients that have these conditions. So we can partition based on, most of the information can be partitioned. So we have many AllegroGraphs that take that data, where each AllegroGraph has only once. I'm explaining this really bad. You get my point, yeah? One patient will wind up only in one database. And that allows us now to do what we call parallel Sparkle, where you can ask a question, you can set that question with a little bit of modification to all your databases, get the results back, combine it again. So you can use all the resources in your system to do very complex queries without using a data mart. Yeah, you can, whatever you want to do, you can do straight on that new platform. This is another way to explain this. Yeah, this enterprise data warehouse. We have a new patented technology where instead of writing a whole bunch of Java code to express how you want to get data out of the source databases as triples, we actually can do it in a completely declarative way, describing the model of our patient, and then annotate the model and tell how it links to information relational databases. Then a big program will read that data and automatically extract the triples and turn it into Hadoop. And so, as I said before, we index it all, and then on top of that, you can write applications to do interesting stuff with the data. For example, machine learning or predictive analytics or cohort selection. I'm going to give you one demo here. No, first a question. So this is what we usually use for our marketing of this. Yeah, we say, okay, read these very complicated queries. Yeah, and if you look at each of these queries, you can easily see that you can't get it only from the EMR database or only from a drug interaction database. No, you really need to combine. So we say, given this query here, find all the patients with cardiac disorder of genetic organ, find the drugs prescribed, use public link data to find potential drug-drug interactions, break down by the hospital within 50 miles of San Jose, and treated by the coronary care units from in this particular time interval. Well, if you look at this query, you have to go to many different types. Cardiac disorder, you go to the diagnosis database. For the genetic origin, you go to another one. And so, in this demo, and I'm not going to explain it today, but you get the point. Yeah, this is a way to express that you need many data sources to answer one query. Now, this query that you saw here actually looks more like this when we actually implemented. This is a first prototype where people can type in natural language, in a mix of natural language and a regular GUI, what you actually want to get out of the database. But I'm going to finish with one demo, and then Aasman can take it over. So one of the interesting things we do is we have all the data in the semantic data lake. You want to do, say, predictive analytics on top. But what do you do with the results of the predictive analytics? So what we do is we apply all kinds of machine learning algorithms to the data. Then we take the output of the data and turn it back into the semantic data lake, and then we can manipulate that data again. So let me go first to the demo. It's not there. Oh, wrong password. And I should have warmed it up, but okay. Let me do it one more time. Okay, so I'll show you this demo, but it actually started with a little story. So a friend of mine has a 4-year-old, and the 4-year-old got half a year ago, for the first time in his life, a spoon with peanut butter. Yeah, 30 minutes later, they were already in the ER trying to save the kid's life, and they saved his life. But then what happened is that the doctor looked at his charts and he said, "Oh, I could have predicted that, because this kid has asthma and dermatitis, and that always goes with peanut allergy." And so my friend says, "Well, why didn't you test him?" And he said, "Well, these kids really hate the tests, and we too." So anyway, my friend was really angry, but that's beside the point. But he knew that we were working on this big data sets. Yeah. So he said, "Jans, can you have a look in your data to see if that's actually true? Because it's very hard to find on the web or in medical handbooks that goes together." So I said, "Okay, I'll have a look." So what I did is I took all the symptoms of 2.7 million patients over 10 years, yeah, and put it into a table. I looked at the co-occurrence between every 2 symptoms, yeah. So how often does a broken leg go with retina loss, yeah? You guys know what an co-occurrence is, yeah? So you compute the co-occurrence, and then you look at the table, and so you look at the distribution of each of these symptoms, and if you can look at what, given the distributions, the value would be for co-occurrence, you can look at the actual value, and then you can compute how many more times the value, current value, is than what it would have been randomly, and they call that the odds ratio. There's many ways you could, on the same technique, you can use chi-square, you can use risk, what is it? Relative risk, and all the other things, but we computed the odds ratio. And then we put the odds ratio back into the tuple store as triples. Yeah, so now we say there's an odds ratio object for disease 1 is peanut allergy, and odds ratio and has 2 say broken leg, and the occurrence is 1.1. Yeah, the odds ratio. So anyway, so I have this thing, and then literally for the first time I did this. Well, I had to build it the first time, but I have it now stored. Odds ratio for peanut allergy. Yeah, so I loaded the query. I have this query where I say, well, give me every odds ratio object from allergy to peanuts to something else. And I run the query, and I was so surprised when I saw the output the first time, because literally this is what the doctor told him. Yeah? And I'm not making this up, truly not. I mean, so here you see dermatitis due to food taken internally, 210 times more than what it would have been randomly. Yeah, same thing for extrinsic asthma and another kind of asthma. Then you get dermatitis again, and then you get acute upper respiratory infections. So I can turn this into a graph. Yeah, so here you have allergy to peanuts, and let me do this. And so I also wanted to know are these things themselves related? Yeah. So I can actually select these secondary symptoms, and I can select the 2 predicates that I need from and to, and I can ask the system, compute the shortest path between each of them. Yeah. In the probability space. And so now if you look at it, yeah, you get this. And if I would keep doing this, here, and I will do it one more time, I will get only wheezing and asthma as the new variables. Let me see here. And if I would take these guys, oh, well, then we have to do this. Nothing else comes up. Oh, Jans, click. Yeah. So what I have here is kind of a perfect cluster around peanuts. Yeah. And I can do this for every disease. And the cool part is now that if you now go to a doctor, then the doctor can look at your history. But with this technique, you can kind of also look at the future, yeah, because you can say, given my symptoms, what are the new symptoms I expect in my first year, second year, third year, or fourth year from now, based on everything else I know in my hospital. And I can take any interesting symptom. One I really like to show when I talk about this is say this one. Odds ratio for lack of housing. No, I have the better one for that one. Okay, so I'm going to test your intuition, yeah? So this is in the Bronx, yeah? Not very, well, a lot of people without homes and all of that. So what are the symptoms most related to lack of housing?
Respiratory.
Huh?
Upper respiratory.
Mental disorders.
Mental. Hypothermia. Okay, I'll show you. Cocaine abuse, cocaine dependency unspecified, and acute alcoholic intoxication. So it's really bad, yeah? And mental problems happen only 2 steps away, and cannabis is 3 steps away. But it's kind of an interesting to ask doctors. I show this to doctors, and I just have them ask in your hospital, I take this disease, what is most related? Now, the database also, let me do this. Now let me first go back to this. Actually, how much time do I have? Otherwise, I'll just go to Aasman, because otherwise it's taking too long. I hope you get this point so far, yeah?
It says 422.
Okay, that's it. Okay, let me just go give it over to Aasman, because otherwise I take too much time. It's fun to do this, but there's so many more.
Just out of curiosity, how do you account for the possibility that a large proportion of the people being brought into the hospitals were done so in custody? So it was like things that they would have gotten picked up for possession of.
Oh, this is not causal. This is just the statistical relationship between lack of housing and this.
Oh, I just wondered.
What the reason? You're probably totally right. Yeah, you're probably totally right. They probably were picked up for something, or.
I just kind of wonder, how would you, as someone who uses this kind of database, account for that selection bias?
Get a database of arrest records.
Possibly, right?
This is always with statistics. I mean, this is the statistical relationship, what it means and how it came about. That is.
I was just curious.
Yeah.
I was trying to think, how would I formulate that? But once you have this big data, it sounds like it's pretty open.
Well, one thing that we do this is very naive, the way this analysis, because more advanced is also to look at the ordering. Yeah, so you look at, if you have dermatitis force, then you look at the next 2 years to find people that also got peanut allergy, or you know what I mean. There's many ways to create that original table, taking into account order effects, the time window that you want to look in, etc. Okay, Aasman, you want to continue? Yeah.
Let me just first thank you for the talk.
Oh, thank you.